Find the probability that z is greater than or equal to negative 0.85. So this, of course, refers to our standard normal variable z. It has a mean of 0, standard deviation of 1, and what we're looking for in A is the probability that z is greater than or equal to negative 0.85. So negative 0.85 is going to be to the left of 0, and we want to find the probability or the area corresponding to the right of negative 0.85. So we go to our table, we look up negative 0.85, and we go down to negative 0.8, and then we have to go across the top to the 0.85 column, which is over here, and the number we come up with is a probability of 0.1977. Now, what this means is that the area in the left tail is 0.1977. And that's why in our z table we have everything to the left of this z here on the box shaded in green. Now, when we go to our problem, we have a right tail. We want to find the probability that z is greater than negative 0.85. So in every case that you see a problem with greater than or equal to, what we're going to use is the complement rule. The probability that z is greater than or equal to negative 0.85 is equal to 1 minus the area in the left tail, which is what we found to be 0.1977. So subtracting these off, we get our answer, which is 0.8023. So remember, for your exam, any greater than or equal to problem, always use the complement rule. So in B, we're asked to find more probabilities corresponding to the z variable, which again is mound shape, has a mean of 0, standard deviation 1, and this time we're looking for the probability z is in between two numbers. So between 0.25 and 2.38. So again, when we go to our z table, we always get the area in the left tail from our diagram. So if we have a problem such as in B, probability that z is in between 0.25 and a number like 2.38, then what we'll have to do is look up the area in the left tail of 2.38, but of course this is not what we want. This is way too much. So what we'll do is we'll look at that number first and then subtract off the area to the left of the 0.25. What will be remaining is the area exactly of what we want. So anytime we have z in between two numbers, we always end up subtracting the probabilities corresponding to the larger z value first. So let's look up 2.38. So 2.3, slide over to the 0.8 column, gives us 0.9913. And again, this is the area to the left of 2.38, 0.9913. And we don't want all of that area. We want to subtract off some. So we don't subtract off 0.25. We have to look up the 0.25, and that's what we subtract off. And that will leave us with the area that's in between, which is just what we want. So let's look up the 0.25 and find that probability next. And 0.25, 0.2, and over to the 0.5 column is 0.5987. And if I subtract these, I get my answer of 0.3923. 0.26. So the probability z is in between these two numbers, about 39%. Finally, C, we're asked a slightly different type of question. We're asked to find the z. We're not given z. We're asked to find z so that the area to the left of z is 0.80. So let's begin with a drawing of our standard normal curve z, and partial credit for the drawing, by the way, on the midterm. And to the left of 0 is 0.5, half of the 1 probability that's under the whole curve. So to the left of the z value, that would give us an area of 0.80. That would bump it over to the right. So we're looking for exactly this z value so that the area in the left tail here is 0.80. So what I do when I'm given a problem where I'm given probabilities, I always put it to 4 decimal places just to remind me where I have to look in the body of the table. So I'm given the left tail in this case, and I need to find the corresponding z. So let's look at our z table and see what we get. So it's going to be something like this. Is probably going to be a positive z value in order to get 80% to the left of it. And here we have 0.72, 72%, 75, 78. Let's scroll over and see how close we can get to 0.80. And it looks like we can get as close as 0.7995. And the two numbers on either side are further away from the 0.80 that we want. So that tells us our z-score that we're looking at, we're working this problem backwards now, starting off with 0.8000, as close as we can get, gives us a z-score of 0.84. So our answer is z equals 0.84 as area to the left of it equal to 0.80.